Good morning, students. Today's part of halogen derivative is nucleophilic substitution reaction. Nucleophilic substitution reaction in aryl halide. Aryl halide shows low reactivity towards substitution reaction. Aryl halide shows low reactivity towards nucleophilic substitution reaction. The low reactivity of aryl halide, it is due to resonance effect in aryl halide and sp2 hybridized carbon atom. Resonance effect of aryl halide and sp2 hybridized carbon atom. Alkyl halide undergoes nucleophilic substitution reaction easily because of in alkyl halide halogen atom is attached to sp3 hybridized carbon, and aryl halide undergoes nucleophilic substitution reaction less effectively because of in aryl halide halogen atom is attached to sp2 hybridized carbon atom. Due to the presence of sp2 hybridized carbon atom, the C-X bond, the carbon halogen bond length decreases due to resonance effect. In aryl halide halogen atom containing lone pair of electron, this lone pair of electrons get delocalized. The lone pair of electrons on halogen atoms and the pi bond electrons in aromatic ring gets delocalized to produce resonance structure. And due to the resonance structure, it produces double bond character between carbon and halogen atom. And due to the formation of double bond character between carbon and halogen atom, the C-X, that is carbon halogen bond length, decreases. And more energy is required to break this carbon halogen bond. The carbon halogen bond in aryl halide decreases due to the delocalization of lone pair of electron and halogen and pi bond electrons in aromatic ring. It produces double bond character between carbon and halogen, and due to the formation of double bond character between carbon and halogen, the bond length between carbon and halogen decreases. Okay, so the bond length in carbon and halogen in chlorobenzene is 169 picometer, and the bond length of C-Cl in alkyl halide is 178 picometer. So which bond is easily broken? C-Cl bond in alkyl chloride, because of it is larger in length. The bond which is smaller in length, it is very difficult to break. Okay, so this is the reason, that is aryl halide shows low reactivity towards nucleophilic substitution reaction. Now, the nucleophilic substitution reaction involves cleavage of C-X bond in haloarine. Nucleophilic substitution reaction involves breaking of C-X bond in haloarine. But when the electron withdrawing groups such as electron withdrawing groups attached to benzene ring in haloarine, if electron withdrawing group attached to benzene ring in haloarine, it increases the reactivity of nucleophilic substitution reaction. It increases the reactivity of nucleophilic substitution reaction if electron withdrawing group attached to aromatic ring in haloarine, then the reactivity of nucleophilic substitution reaction increases. And if electron withdrawing group is attached to ortho or para position in haloarine, then the nucleophilic substitution reaction undergoes more effectively, because of electron withdrawing groups like NO2 stabilize more effectively the negative charge on carbon atom. There is a delocalization of pi bond electrons and lone pairs of electrons at ortho and para position. The delocalization of pi bond electrons and lone pair of electron can be take place more effectively if electron withdrawing group attached to aromatic ring in haloarine. Okay, for example, chlorobenzene containing one NO2 group at para position. Here chlorobenzene. Nucleophilic substitution reaction here. This reaction represents nucleophilic substitution reaction. In this reaction, Cl is replaced by nucleophile OH minus. So, p-nitrochlorobenzene, when it is treated with NaOH at about 433 Kelvin, and after acid hydrolysis reaction, it produces p-nitrophenol. Cl is replaced by OH. But in second reaction, there is a 2NO2 group. NO2 group is known as electron withdrawing group. जर इलेक्ट्रॉन विथड्रॉइंग ग्रुप बेन्झिनला जोडलेले असतील तर न्यूक्लियोफिलिक सबस्टिट्यूशन रिॲक्शन इफेक्टिव्हली होते, कारण नेगेटिव्ह चार्ज ॲरोमॅटिक रिंगवरचा इफेक्टिव्हली डिलोकलाइज होतो. ओके, सो in second example there is a 2 electron withdrawing group, so that's why the nucleophilic substitution reaction can be carried out more effectively. As the number of electron withdrawing group increases, the reactivity towards nucleophilic substitution reaction also increases. So that is 2,4-dinitro-chlorobenzene when it is treated with the aqueous solution of sodium carbonate at about 403 Kelvin. Temperature कमी झाले बघा पहिल्या रिएक्शन मध्ये. इन फर्स्ट रिएक्शन द टेम्परेचर रिक्वायर्ड इज 433 Kelvin, and but in second reaction the temperature is required 403 Kelvin. It is lower than 433 Kelvin. And after acid hydrolysis reaction, it produces 2,4-dinitrophenol. But in the third example, there is a 3 electron withdrawing group, 3NO2 group. So that's why reactivity also increases. So when 2,4,6-trinitrochlorobenzene is warm with NaOH, NaOH दिलेलं नाही तिथे, it undergoes hydrolysis reaction, it produces 2,4,6-trinitrophenol. It produces 2,4,6-trinitrophenol. This is the nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. Now, electrophilic substitution reaction in aryl halide. Electrophilic substitution reaction in aryl halide. Electrophiles like chlorine, bromine, iodine, sulfonic acid. Okay, so first electrophilic substitution reaction. First of all, explanation. Here, इथे दिलेला आहे identify product A of the following reaction. What is the product? Benzene when treated with nitric acid in presence of concentrated sulfuric acid, it produces nitrobenzene. That is the product. It produces nitrobenzene or 1,4-dinitrobenzene. 1,4-dinitrobenzene or nitrobenzene. Okay, mixture of 1,4-dinitrobenzene or nitrobenzene. Okay, aryl halide undergoes electrophilic substitution reaction slowly as compared to benzene. Aryl halide undergoes electrophilic substitution reaction slowly as compared to benzene. In resonance structure of chlorobenzene, see here 10.5 resonance structure. In this resonance structure, this is the resonance structure of chlorobenzene. Okay, resonance structure of chlorobenzene. Now, in resonance structure of chlorobenzene, electron density is relatively more at ortho and para position. Therefore, incoming electrophilic group is more likely to attack at this position, but due to steric hindrance at ortho position and para position, products usually predominates. Okay, in haloarenes, halogen atoms have strong electron withdrawing group, that is inductive effect, negative inductive effect. This deactivates the ring and electrophilic substitution reaction occurs slowly. Okay, so next, halogenation reaction. This is electrophilic substitution reaction, halogenation reaction. When chlorobenzene is treated with chlorine in presence of anhydrous ferric chloride, when chlorobenzene is treated with chlorine in presence of anhydrous ferric chloride, it undergoes chlorination reaction and it produces 1,4-dichlorobenzene, that is major product, and 1,2-dichlorobenzene, it is minor product. Okay, so this is first electrophilic substitution reaction. Second one, nitration. When chlorobenzene is treated with concentrated nitric acid, when chlorobenzene is heated with concentrated nitric acid and concentrated sulfuric acid, it produces 1-chloro-4-nitrobenzene as a major product and 1-chloro-2-nitrobenzene as a minor product. When chlorobenzene is heated with concentrated nitric acid in presence of concentrated sulfuric acid, this mixture is known as nitrating mixture. When chlorobenzene is heated with nitrating mixture, that is nitric acid and concentrated sulfuric acid, it undergoes nitration reaction. It produces 1-chloro-4-nitrobenzene as a major product and 1-chloro-2-nitrobenzene as a minor product. That is nitration reaction. Now sulfonation reaction. Sulfonation reaction is carried out by heating haloarenes with fuming sulfuric acid, H2SO4. When chlorobenzene is heated with fuming sulfuric acid, H2SO4, it undergoes sulfonation reaction and it produces 1-chlorobenzene sulfonic acid as a minor product and 4-chlorobenzene sulfonic acid as a major product. Okay, 1-chlorobenzene sulfonic acid, this is minor product, and 4-chlorobenzene sulfonic acid as a major product. This is sulfonation reaction. And last one is Friedel-Crafts reaction. There are two types of Friedel-Crafts reaction: Friedel-Crafts alkylation reaction and Friedel-Crafts acylation reaction. What is Friedel-Crafts alkylation reaction or acylation reaction? The introduction of alkyl or acyl group in benzene. The introduction of alkyl or acyl group in benzene ring by the reaction of alkyl halide or acyl chloride in presence of anhydrous aluminum chloride. It is known as Friedel-Crafts alkylation or acylation reaction. It is carried out by treating haloarenes with alkyl chloride or acyl chloride in presence of anhydrous aluminum chloride as a catalyst. When chlorobenzene is treated with methyl chloride in presence of anhydrous aluminum chloride, it produces 1-chlorotoluene and 4-chlorotoluene. 1-chlorotoluene and 4-chlorotoluene. That is the formation of compound. Now, when chlorobenzene is treated with acetyl chloride, in presence of anhydrous aluminum chloride, it produces 1-chloroacetophenone and 4-chloroacetophenone. 1-chloroacetophenone and 2-chloroacetophenone. Okay, so that is formation of acetophenone, and these are the electrophilic substitution reaction. 4 substitution reactions are there. First one is chlorination, second one is nitration, third one is sulfonation, and fourth one is Friedel-Crafts reaction. Okay, now here some uses and environmental effects are given for the compound. First one is dichloromethane, second one is chloroform, third one is carbon tetrachloride, next one is iodoform, triiodomethane, fifth one is freon, and sixth one is DDT, diphenyl trichloromethane. This is known as DDT, and these uses and environmental effects are very important. ते तुम्ही वाचा, लक्षात पुस्तकात दिलेले आहेत. ओके, so this is the today's part. Thank you.